Thank you, Pete. Hello, everyone. My name is Colin Nebocat, and I'm the Chief Technology Officer of Blockchain Infrastructure Research. In this 15-minute presentation, I will be providing insight into how to make the most of your GPU-based cryptocurrency mine. Specifically, I'll be talking about alternative industries and use cases for GPU compute power with a focus on hardware, software, and data center requirements to effectively transition out of mining in whole or in part. Sorry, my screen shut off up here. Okay. In order to conduct our research and verify new innovations in the crypto mining space, BIR has built its own dedicated lab facility located in the Greater Vancouver area. With this facility, it is my job to experiment with different hardware and software to figure out what works well and what doesn't. For instance, one of my more interesting and ongoing projects is developing software for deploying pre-configured disk images via network booting to rapidly deploy new mining software across multiple rigs at once. In January 2018, the price of Ethereum had just peaked around $1,260 US, and there was major interest in crypto from all types of investors. As such, the development of our test lab started in February 2018 and was designed around GPU-based systems thanks to the potential of GPUs to mine a multitude of different coins and algorithms. We specifically did not choose Bitcoin mining on ASICs due to their limited application scope, accelerated obsolescence timelines, and other Bitmain-related snags. By May 2018, the lab was ready, and we started testing the Ethos mining software because of its popularity and ease of use. However, during our testing, we noticed that over time, rigs would slowly die off one by one. When mining stopped, rigs would hang but not power off, which cost us power unnecessarily. After realizing that Ethos was unstable, caused excessive downtime, and wasted electricity, we decided it was time to test out some new software. We chose the Claymore mining software because it was bare bones and the community had mostly positive experiences with it. Claymore was a little more difficult to set up on our Linux machines, but that was forgiven due to a dramatic increase in hash rates. On Ethos, we were achieving about 230 hashes per second, but our rigs on Claymore jumped up to 282 hashes. At one point, this 23% increase in performance enabled us to mine over 2 ETH per day. Furthermore, the stability in Claymore was much better, enabling us to mine longer with less downtime. Then came the fall of last year. The price of Bitcoin and most other cryptocurrencies spiraled downwards in one of the largest market adjustments to date. Since we are a research-based startup, we can only afford to run the lab if it pays for itself. Thus, for my next point, I'm going to take us back to Microeconomics 101 and review the concept of the shutdown rule. The shutdown rule dictates that a mine or other business should only produce if marginal revenue is greater than its marginal cost. This is shown here on the graph where the blue and green line meets, although it's hard to see. Due to the bear market last fall, we indeed shut down the lab in late November of last year. At this time, we decided to seriously start investigating other use cases for GPU-based data centers since we expected mining companies to be looking for alternative sources of revenue as well. This is an ongoing research project that is constantly evolving, entails a lot of secondary online research, and even primary research in the form of one-on-one interviews and focus groups. Currently, there are 2 main use cases that look promising. The first being artificial intelligence and deep learning, while the second being the visual effects and 3D animation rendering used in film and video production. Both of these 2 use cases rely dramatically on GPUs for increased performance and output over traditional CPU counterparts, so much so that GPU manufacturer NVIDIA is investing heavily in these 2 verticals. In fact, our continued research on this topic includes a trip to San Jose next week, where my colleague Micah and I will attend the NVIDIA GPU Technology Conference, where we will learn about the latest developments in GPU tech direct from industry leaders. So just what is AI and deep learning? Artificial intelligence is the concept of machines becoming intelligent like humans. AI, like those depicted in sci-fi films, is actually referred to as general artificial intelligence and is arguably still quite out of reach. On the other hand, deep learning is a subset of AI, which is merely one technique of enabling computers to teach themselves how to identify or classify data, so they can then, for example, recognize objects in a frame or interpret a passage of text as a human would. Currently, leading companies like Uber, Tesla, and Mercedes-Benz are using deep learning to enable computer vision for their vehicles, so their cars can literally see and detect objects on the road. Given the recent explosion in deep learning, GPU-based data centers are well positioned to provide the high compute capabilities that the training of deep learning models requires. Specifically, the training of models refers to the computing process where GPUs handle the multiple matrix multiplications of deep learning algorithms in parallel, as opposed to the sequential operations of CPUs. If you are a large GPU-based data center, you can potentially repurpose your GPU rigs for deep learning to earn higher returns. However, unlike crypto mining, deep learning training requires beefed up CPUs, motherboards, memory, and GPU RAM. In our hardware research, we found that the number of PCIe lanes and their bandwidth speeds are the most limiting factors for converting mining rigs into deep learning rigs demanded by data scientists. Mining rigs usually have low-end CPUs with only 16 lanes of PCIe connected through ×1 or ×4 speed motherboards, while optimal deep learning rigs require GPUs running on PCIe lanes of at least ×8 speed. This requirement, in turn, limits the GPU count per rig to a maximum of 2 for most consumer-grade motherboards. Consequently, this lower GPU to rig ratio can dramatically increase the capital expense required for transitioning. Next, if you're willing to invest into upgrading your GPU rigs, you will need to find a place to sell this compute power. Unfortunately, major cloud providers like AWS and GCP already hold a large market share. Although the sense in the general community is that AWS and GCP can get expensive quite quickly at $350 to $250 US per hour respectively for a single Tesla V100 GPU rig. In terms of consumer demand, we've conducted an online research survey where over 50% of respondents reported they would pay a cloud provider for deep learning services. 60% of respondents claim to have spent an average of $2,700 Canadian in the last year for training their models in the cloud. And over 90% of respondents said that access to high-power computing was limiting their productivity. Thus, for transitioning crypto miners, entering the lower-price market will probably be a better choice due to hardware limitations, where pricing ranges anywhere from 30 to 90 cents US per GPU per hour. All right, now that we have an understanding of what deep learning is, how we can leverage our existing GPU hardware, and have a basic sense of the market, let's look at our two primary transition options. Option 1, become a cloud provider. With this option, crypto mines will become their own cloud provider and compete with others in the lower-end market for deep learning training jobs, while crypto mining in downtime. Primary market segments will include freelance data scientists who work independently, student data scientists at universities who have limited incomes, small AI consultancy firms who lack data center management expertise, and AI-based startups working on lean budgets. Miners will then need to build a brand specific to deep learning, set up and maintain rigs with the appropriate AI software and frameworks, and finally launch a web app that will handle and process jobs for their new service. Option 2, join a marketplace. If option 2 sounds like too much risk, or if option 1 sounds like too much risk, option 2 is a simple way to transition. Luckily, there are two notable marketplaces where miners can list their rigs to be available for rental from a pre-acquired customer base. We have yet to try listing our machines on these sites because they have strict hardware requirements to join. However, 06.ai estimates income from 15 cents to $1 US per hour if rented, while Vast AI implements a bid system where miners can vary the price of their machines based on demand. The next use case for GPU compute power is the visual effects and 3D animation rendering used in film and video production. Visual effects and 3D animation is everywhere these days, and it seems like every other movie release is a superhero action flick. Even a non-Netflix series incorporates much more visual effects than one may expect. Traditionally, CPUs have been the component of choice for VFX rendering and are still the primary component today in many production pipelines. However, the new GPUs like NVIDIA's Quadro RTX 8000 with 48 gigabytes of VRAM, rendering on GPUs is and will become more and more prevalent throughout this industry. Damien Fagnew, CTO of Moving Picture Company, who produced the VFX for the film The Martian starring Matt Damon, cites the major benefits of rendering on modern GPUs to include reliability, certification of major software applications, engineering support, driver stability, and performance that is unprecedented by the competition. In terms of hardware requirements, again, the demand for upgraded system components remains higher than that of conventional crypto mining setups. The process of rendering is a process in which a render engine translates millions of 3D data points into the color and brightness data for each pixel displayed on a 2D screen. GPUs provide an advantage in this process over CPUs thanks to their inherent parallel computing architecture, which allows them to run tasks concurrently. To demonstrate these performance gains, I'm showing here two test results from some Chaos Group V-Ray benchmarking test trials that we performed. As you can see on the left, our standard mining rig with 6 GPUs running on PCIe lanes at ×1 speed completed the test in 36.5 seconds, while the configuration of the same 4 GPUs on an upgraded CPU and motherboard completed the test in 17.8 seconds. That's literally twice as fast thanks to about $800 worth of upgrades. According to IBIS World, visual effects and animation and 3D visual effects studio segments make up a $630 million industry in Canada alone. In recent years, Canada and Hollywood North have had a major advantage of being home to a large supply of VFX studio talent and a low Canadian dollar for major US movie studios and television producers to take advantage of. As such, GPU-based miners capable of providing low latency, local render farm solutions in the Greater Vancouver or Toronto regions should be able to obtain strong first mover advantages and build lasting relationships within this tight-knit industry. Globally, however, the market is quite saturated with more than 44 professional render farms offering GPU rendering services only a quick Google search away at costs as low as 25 cents US per GPU per hour. Unfortunately, transitioning into the VFX and animation rendering space is not as simple as deep learning, since I have not yet found any marketplace solutions. Starting a render farm will primarily be an exercise in marketing and sales, built upon a custom software solution for accepting and processing jobs effectively. Furthermore, there are added costs to rendering as it is not built upon open source software like deep learning. Software licensing for a single node on a render engine may be as high as 50 cents US per hour per GPU, or may be structured as a commission fee of up to 20% of total project revenue. Nonetheless, future demand for entertainment and rendering seems almost limitless as more and more media is produced and consumed digitally, while simultaneously the rendering industry is shifting away from CPUs to GPUs for their rendering needs. In this talk, I've covered 3 use cases for GPUs, including crypto mining, AI and deep learning model training, and finally, VFX and 3D rendering. For GPU-based mine managers, I believe it will be wise to consider diversifying your mine's revenue streams into these activities, since I feel Bitcoin and crypto has lost its major speculative investment appeal, and prices may remain depressed for the short midterm future. It is also important to note that both of these alternatives are job-based systems, so your facility may not be running at full tilt 24/7, so you can potentially still mine during downtimes. On a last note, we've got some used items for sale out here just because we're transitioning equipment all the time. If you're interested in any of those, or you'd like to know more about my talk or get performance tips on calculating metrics for your mine, please come and find me. On behalf of Blockchain Infrastructure Research, thanks again and enjoy your lunch.